The next step will require a little bit of effort. Consider a matrix with 3 rows and 3 columns. We will call it A and the entries A, I, J as usual. We calculate its determinant using the definition. Then we select the first row and add the products of the entries of that row times their cofactor. A11 is in even position, then cofactor and first minor coincide. We multiply it by the determinant of the submatrix that I obtain removing the first row and the first column, as you see. Now I take the second element of the first row and I notice that it is in odd position. Then I immediately use the sign minus and then remove A12 multiplied by its first minor, that is the determinant of the submatrix that I obtain from A, removing the first row and the second column, that is the submatrix A21, A23, A31, A33. Now I take the last element of the row, A13, 1 plus 3 is, of course, even, then I multiply by the cofactor, that is the first minor, they coincide in every even position, the determinant of the submatrix that I obtain from A, removing the first row and third column, the submatrix A21, A22, A31, A32. What we have just written is the determinant with the definition. And remark, we have not yet calculated it. It's just a matter of writing the elements that are involved in the calculation, removing rows and columns that are step by step unnecessary. Only now I perform the direct calculation of the 3 determinants of the 2 by 2 submatrices that are involved. Check if I am doing it right. Now I have to perform 3 products, and I rearrange the result, writing first the products that are introduced by a plus, that I denote in yellow, and then I add the 3 products that are introduced by a minus, that I denote in light blue. You can read the result on your screen, and of course, this 3 by 3 case involves a formula that it's harder to be remembered than the formulas concerning the 2 by 2 or the simplest case, the 1 by 1 matrix. Is there any simple way to remember this sequence of entries that give the determinant of the 3 by 3 matrix? Well, there is one way, and the idea is that of connecting the coefficients with the position inside the matrix. Let me denote with a specific symbol every entry of the triads that denotes the terms that are added in the formula in yellow. Now I have to find a simple way to remember which are the elements denoted by the triangle, which denoted with the circle, and which denoted with the star. I rewrite at the right of the matrix the first and the second column, and it's simple to recognize that the product of the triangular element, the product of the circled element, the product of the star elements are all parallel to the main diagonal of the matrix. In an analogous way, I want to recognize the elements of the triads in blue that are removed in the calculation of the determinant, and I denote the elements with a circle, with a star, and with a triangle, for instance. If I rewrite at the right of the matrix the first and the second column, I recognize the triad denoted with the circle, the triad denoted with the star, and the triad denoted with the triangle as being parallel to the secondary diagonal of the matrix. Hence, the rule for the calculation of the determinant of a 3 by 3 requires to add the product of the threads that are parallel to the main diagonal and remove the product of the threads that is parallel to the anti-diagonal. Remark, this is the definition of determinant, while this is a formula that we have obtained for the calculation in the 3 by 3 case, and it holds only in the 3 by 3 case. This is known to be the Sarrus rule. Don't apply it to larger matrices.